Hi all, welcome to our brand new workbook. This is going to be the second half of Unit 6 with a focus on graphing. In order to graph though, we really need to make sure we have all of our vocabulary down and that we're comfortable with it so that we can all use the same words when we're discussing parts of graphs and their characteristics. So let's get right into our important vocabulary for this unit. If you have a highlighter, that would be great to highlight all of these keywords. So I will be highlighting these as we go. So for example, these are the first three on my screen, so I will highlight these first. Let's first talk about the vertex. That is a word we've mentioned a couple times, but we haven't formally defined it yet. The vertex, by definition, is the highest or lowest point, also known as the maximum or minimum. So if we look at this graph, where would my maximum or minimum be? Where is that point? Well, here this is opening up, so I have a lowest point, which should be right there. This would be a minimum, and as a result, it would also be the vertex, or vice versa. This is our vertex, therefore it is the minimum point on the graph. Axis of symmetry. Axis of symmetry, also known as AOS for short, is the vertical line that splits the parabola and when we say parabola, we're talking about this shape here, equally in half. The equation for the axis of symmetry is x equals the x value of the vertex. So let's see how that would apply to our graph here on the right. We're looking for a vertical line that splits the parabola equally in half, and I know that it passes through the x value of the vertex. Well, here's my vertex. So here is an invisible vertical line passing through the x value of the vertex. And if I were to write the equation of that line in general, it's going to be x equals a number because it's a vertical line. What is the x value of the vertex? Well, if I trace this up, I see that we are at -1. So x equals -1 is the AOS, or axis of symmetry. Let's now talk about our first quadratic form that we're going to discuss, which is standard form. Standard form, by definition, is f of x equals ax squared plus bx plus c, and we are familiar with this because when we were factoring, we were working with standard form. This is the key though, so our new learning as it relates to standard form is how to find the vertex. So to find the vertex, substitute in B and A into the formula xv, x sub v equals negative b divided by 2a. So that will get you the x value of the vertex. Once I have the x value, how do I find the y value? Well, as always, when we have x and we have a function, we can evaluate f of x. So in this case, we will do f of whatever the result is. So let's say this negative b divided by 2a got me 5. I would then do f of 5. So f of x sub v means sub xv, or x sub v is how we really should say that, into the original function, f of x, to find the y value of the vertex. So this is the key here, and we'll be using this a lot. So I would make that stand out in your notes, put a big star next to it, put an arrow. It's going to be big for us here. Next, let's discuss vertex form. I want that to stand out in my notes, so I will highlight it. And once again, we're going to first discuss how to find the vertex. I'm hoping it catches our attention that this is called vertex form, and we are looking to find the vertex. So let's see why they share a common vocabulary word. So to find the vertex, identify the h and k values. The vertex will be the ordered pair h, k. So what's pretty awesome is that I literally can identify h and k, and I'm done. We have no algebra to do. So in standard form, we have some work to do, but in vertex form, we won't. What we do need to pay attention to, though, is this built-in negative. So let's make a little note. Remember, the minus sign is part of the formula. The minus sign is part of the formula. And why is that important? Well, let's say I have, so I'll put a little example. Let's say I have x plus 8. Well, that really means x minus a negative 8. Because again, if I look here, it says x minus h. So it comes with a built-in negative, which means it's really x minus a negative 8. So here, in this little example we're doing right now, h would be negative. So when we see a positive, really a negative value is plugged in to make that built-in negative become positive. And we'll definitely be practicing, so no worries. Just make sure we have this note down though, so that we can reference it when we're studying. Next, let's discuss the effects of A. We have a little bit of experience with A. We started some sketching. So my first hope is that as we start discussing the effects of A, we remember what happens if we have a positive A versus a negative A. If we have a positive A, I'm hoping we're all thinking to ourselves that the parabola will open up. The parabola will open up. If we have a negative A, the parabola will open down. So by opening up, we mean literally opening up, and down would look like this. So this piece is prior knowledge. We knew that. But let's now discuss how A affects the width of the parabola. If A equals 1, I'm going to change the color of this. If A equals 1, parabola has normal width. Meaning it's not wide and it's not narrow. So if you kind of think of that standard parabola shape, that's what normal would look like. If A is greater than 1, parabola is more narrow, meaning it gets skinnier. And the last possibility here is A is between 0 and 1. So like a fraction like 1/3, 2/5. If A is between 0 and 1, the parabola is more wide. So here we have our visual of what normal would be, narrow and more wide. So some examples of A values that would cause it to be narrow. Let's say A was, what's a value bigger than 1? 4, maybe 2, how about 6, right? All of those would work. Those are all A values greater than 1. But for more narrow, just making this match. So for narrow, values bigger than 1. 2, 3, 4, 5, 6, 7, 8, 9. But for more wide, we would be looking at A values like 1/2, 3/4, 2/5. Those are all values between 0 and 1. A quick note, positive or negative A does not affect width. And we actually kind of know that, but we want to make a more clear statement. Positive A or negative A does not affect the width. Because if we look here, positive or negative A just affects whether or not the graph opens up or down. So when we're looking at whether or not A is greater than 1 or between 0 and 1, whether or not these values are positive or negative does not matter. You're just looking at the number itself or if we were using our math vocabulary, to be more clear, the absolute value of A. So ignore the sign and just look at the number. Put that in quotes. Ignore the sign and just look at the number. So what we're really saying is the absolute value of A when we're determining width being normal, narrow, or more wide. Let's now discuss shifts. So we have a continuation of our vocabulary toolbox. I'll take a second to highlight these key words. Let's first discuss what shifts are. The vertex causes the parent function to shift left, right, left, right, and or up and down. So for example, if I were to look at, I'm going to put this picture over here. My original graph is y equals x squared. So this is what y equals x squared looks like. Nothing has happened to it. No shifts whatsoever. But let's say the graph has now been shifted down here, and I know that the vertex is located at 4, negative 6. That would mean the graph, so vertex, a vertex of 4, negative 6 would tell us shift, let's see, my original vertex was right here. So we shifted right by a factor of 4, so that came from the x value of the vertex. Shift right 4, that should say right. Okay, shift right 4, and then is that the only shift? Well, no, because if I only shifted right 4, my parabola would be up here, and that's not where it is. So not only was the parabola shifted right 4, but it was also shifted down 6. So this is what we mean by saying that the vertex causes the parent function, which here is in blue, to shift left or right, and or up and down. And the reason why I put and or is because it could have just moved to the right and then stayed there. Or it could have shifted down and just stayed there. So sometimes you'll have a shift left and right and up and down, or maybe it's just left or right or just up and down. And we'll continue to practice, of course, but the key is to make this connection that xv, the x value of the vertex, x sub v, equals horizontal shift and y sub v, which is the y value of the vertex, will always get us our vertical shift. Let's now discuss domain. If I look at the graph that I just drew, remember that domain is all about the which values? And I'm hoping we're all thinking x, and I would say, yes, you're right. So for the domain, we're coming in from the left and right. So if I look at, maybe I'll resketch it so that we don't look at two, we just look at one of them. When I look at this parabola, to make it interesting, I'll shift it down. And I come in from the left and the right. From the left, I hit an arrow, and from the right, I hit an arrow. And this will be true for all parabolas. So for the domain, no restrictions. There will never be a restriction. And so we can indicate that by saying that the domain is either negative infinity to infinity, or we could use the all real numbers symbol. Now let's talk about the range. Range is all about y. And again, we'll come in from the bottom and then come in from the top, bringing back that prior knowledge. So coming in from the bottom, I definitely don't hit an arrow. And this is our minimum point, which means it is the vertex. So the range will always be restricted by the vertex. So let's make that as a statement. The vertex restricts the range. So for example, with this graph that's opening up, so let's say I have a graph that's opening up, and I'll resketch it. Make it small because we're going to fit another graph underneath it. Again, this is x sub v, comma y sub v. If I asked you to find the range, you come in from the bottom, you're going to hit that y value of the vertex as the lowest possible y value. So that would be bracket whatever that y value of the vertex is, and then when I come in from the top, I do hit arrows. So that would be to infinity, with a parenthesis because we can't equal infinity. What if this graph was opening down? So now let's talk about a negative a value. So now we have a graph that's opening down. This is still x sub v, comma y sub v. As always, let's come in from the bottom first. When I come in from the bottom, I hit arrows. So that'll be negative infinity. Now when I come in from the top, once again, I'm restricted by this y value. In this case, it's a maximum, so it's the biggest y value we're going to possibly have. So it's going to be y sub v with a bracket. So the big takeaway here is that the domain will never have a restriction. The range always will have a restriction directly connected to the y value of the vertex. Let's now discuss x-intercepts. So for x-intercepts, we have three possibilities. And just to make sure we're all on the same page, x-intercepts is where the graph crosses the x-axis. If you need to write that note, you can. where the graph crosses the x-axis. So our first possibility is that there's none. So what will it look like if we have 0 x-intercepts? So let's create a sketch here. But if I have no x-intercepts, for that to happen, it means I'm never going to cross the x-axis. So that could happen if my graph has shifted up and is opening up, or is shifted down and opening down. So if you notice, neither of these two graphs will ever cross the x-axis. So these are examples of having no x-intercepts. Second, we could have 1. Let's see what it looks like if we have 1 x-intercept. To have 1 x-intercept literally means the parabola will only intersect or touch the x-axis one time. So what that means is that my vertex is actually sitting right on the x-axis. So we could have a parabola opening up or down. But notice in both cases, we only have 1 x-intercept. Last but not least, we could have 2 x-intercepts. For that to happen, my graph would need to be shifted down and open up. And as soon as that happens, notice it must cross twice. Once right here, and once right here. So that's if the graph was shifted down. What if the graph was shifted up? Well, if it's shifted up to have 2 x-intercepts, we would then need to have that graph opening down. So both of these are examples of what it would mean for the graph to have 2 x-intercepts. So in summary, we can have none, 1, or 2. Discussing the y-intercept, so that is where the graph crosses. The y-axis. We have 2 cases. The first case is for standard form. Who remembers what standard form is? Standard form was f of x equals ax squared plus bx plus c. What's really nice about standard form is that the c value ends up being my y-intercept. And in green, or purple, let's do purple. I'm going to put the reason why. To find the y-intercept, we will always let x be 0. So if I let f be 0, let's see what happens. A times 0 squared plus b times 0 plus c. So 0 squared times anything, that's 0. That will cancel. b times 0 is also 0, and that just leaves behind c. So if I have standard form, the c value is automatically my y-intercept. Vertex form is going to work a little different because we don't have this nice canceling happen. So my vertex form again in general is f of x equals x minus h all squared plus k. I'm going to show you why it doesn't work, so don't write this down, just watch. If I do f of 0, it's going to be 0 minus h squared plus k. If you notice, we can actually do this subtraction. So like for example, if h was 5, 0 minus 5 would be negative 5 squared is 25. So we don't have this nice canceling happen, which means we will have to do a little bit of algebra, not too bad. So for vertex form, must calculate f of 0 to find that y-intercept. So we now have our complete vocabulary toolbox. Let's see how this will work when we apply it to a given quadratic. So it says for each example, describe the role of A, determine the vertex, axis of symmetry, shifts, domain, range, and y-intercept. So we're about to use all of that vocabulary that we just learned. Looking at number 1, my first question is going to be, what form is this in? And I'm hoping we're all saying vertex form. And it is in vertex form. To discuss the role of A, we first have to identify A. So what is A? Well, up top I can help myself out and write A times x minus h all squared plus k. So I know that here A is negative 1/2. So first let's decide, is this positive or negative? And it is negative. So negative A means that this graph will open down. And then is A greater than 1 or between 0 and 1? And remember, we are not going to look at the negative sign. So I'm just looking at that number 1/2. So here, when I look at my A value, A is between 0 and 1 because we're just looking at that number 1/2. Is that more wide or more narrow? Flipping back over, go look, more wide or more narrow? And the answer is more wide. Next, identifying the vertex. Recall that my vertex is h comma k. So if I look, remember there's a built-in negative. So here h is 5 and k is 8. My axis of symmetry comes from where? Go check it out. Where does the axis of symmetry come from? Looking at the notes we started with, we learned that the axis of symmetry comes from the x value of the vertex. So for us here, what was the x value of the vertex? And I'm done. As soon as I identify the x value of the vertex, I know exactly how to write the axis of symmetry. The shifts are directly connected to the vertex, remember. So my x value of the vertex is 5, and the y value of the vertex is 8. This means that my graph was shifted or shift right 5, and here this will be a shift up 8. Remember, the x value always tells me left or right, so because it's a positive 5, right 5, and the y value of the vertex always tells me up or down. In this case, 8 is positive, so that's a shift up. My domain will always be all real numbers. And before we talk about the range, let's do a quick sketch. So let's see how all this comes together for what we have so far. Knowing that a is negative 1/2 won't help me until I've actually plotted my vertex. So let's plot the vertex first. 5, and then up 8 will be somewhere up here. Now that I have the vertex, now I can use this information. I know that the graph's going to open down and be more wide. So we just successfully sketched a graph that is shifted right 5, up 8, opens down, and is more wide. And when we have the sketch, it definitely helps us decide on the range, because when I come in from the bottom, I see that I'm going to be hitting some arrows, so that's negative infinity. And when I come in from the top, ask yourself, what is the largest y value you have here? And that will always be here, the y value of the vertex. So I know that my range is negative infinity, comma, 8. We are working in vertex form, which means we do not get the y-intercept for free. We will need to calculate f of 0. So let's do that. Let me see if I can fit the original. I'll move this down in just 1 second, but it's going to be, I'm reading from it right here, f of 0 will be negative 1/2 0 minus 5 times 0 minus 5 squared plus 8. So we are literally plugging in 0 for x. So that's going to be negative 1/2 times negative 5 squared plus 8. What's negative 5 squared? That is a positive 25. What's half of 25? Well, I think half of 24 is 12. So half of 25 isn't that much bigger. It's just up by 0.5. Excuse me. So half of 25 is 12.5. Don't drop the negative. And we do need to add 8 to that. And we get negative 4.5. So that means that my y-intercept is at 0, comma, negative 4.5. So that was an example of vertex form. Let's now take a look at number 2. What form is this in? This is in standard form. So we'll have one example in vertex form and one example in standard form. Role of A. So let's pick it back up. Let's go through the same list. Here A is 3. And what does that tell me? Well, let's go back. To talk about A, we decided, does it open up or down? And is it wide? Is it normal? Is it narrow? So first I see that it's a positive A, which tells me that this will open up. And then just looking at the number, is it greater than 1? Between 0 and 1? I'm hoping we're saying greater than 1, and I agree, which means that it's going to be more narrow. Now the vertex we're going to have to do a little work for, because we are not given vertex form. So remember, it's going to be negative b divided by 2a. So to do that, we have to know what b is and what a is. So b is negative 12. So for us right now, we've got b is negative 12 and a is 3. So notice it says negative b. So that's going to become negative 12 divided by 2 times 3. Negative turns into a positive. 2 times 3 is 6. 12 divided by 6 is 2. We've got the x value of the vertex. How are we going to find the y value? Well, in our notes, we talked about how once we have the x value, we can go plug it in. So let's do that. It's going to be g of 2 equals 3 times 2 squared minus 12 times 2 plus 1. Two squared is 4 minus 24 plus 1. And now I'm just using my algebra skills to finish evaluating this. 12 minus 24 is a negative 12 plus 1. We get negative 11. So I have found the vertex to be 2, negative 11. Axis of symmetry is connected to the x value of the vertex. So now that I calculated the vertex, I'm in good shape. I know that the axis of symmetry will be at 2. So I don't think we drew it in here. We should have. For up here was at x equals 5. So that's that invisible line that cuts it in half. And let's discuss shifts. The x value of the vertex is 2. The y value of the vertex is negative 11. So if the x value of the vertex is 2, that tells me that the graph has been shifted left or right. I'm hoping we're all thinking to the right, and I agree. Shift right 2. Y value of the vertex determines up and down, so this is going to be a shift down 11. And I'm just going to, so we can visually distinguish this, I've been switching back and forth in colors, so I'm going to make this. There we go. Domain is always all real numbers, which is nice. To determine the range, let's get our sketch. So off to the side here. I know my vertex is at 2, negative 11. And how do I know how to sketch this? Well, I come back up here. I know that it's opening up and it's more narrow. So opening up and more narrow. My vertex is at 2, negative 11. and my axis of symmetry goes through the x value of the vertex. Its equation is x equals 2. So the vertex and the a value tell us a lot, which is nice. Now that we have the picture, it's a little easier for us to determine the range. Coming in from the bottom, what's that smallest y value possible? From the vertex here, I know it's going to be negative 11. Because that's that minimum point. There is no point lower than the vertex here. And when I come in from the top, I hit arrows. So positive infinity. Last but not least, y-intercept. Remember, when we have standard form, this one is nice because I get it for free. So looking at my original given function, 1 is my y-intercept. So my graph should be a little, you don't have to change yours, but to make this a little more accurate, it should be crossing at 1. So I'll just shift mine over. So here's that intercept at 0, 1. This completes our notes for day 1. And these two examples are going to be the foundation for your practice tonight for the homework. So we have a full example of vertex form, and we have a full example of standard form. Your job will be to practice working on 3 and 4 for homework. So just 2 for homework. Number 3 and number 4. Remember to pay attention to details and really use the notes we took, the vocabulary, and the 2 examples as a guide for how you work on these 2 homework questions. Have a great night, and any questions, please, as always, send me a reminder.